Hi, I'm Phil Normandeau, Surficial geologist at the NTGS. Welcome to this part of the 2020 Geoscience Symposium. Thank you for embracing this year's format and this way of doing things. Uh, so we'll get started with my talk, which is a surficial geology, glacial history, and bedrock investigation in the Desert Lake drumlin field in Northwest Territory. So I'm basically quickly going to talk about this project that I'm doing with my co-author Gideon Lembiv et moi. And yeah, let's get talk started.
All right, so as mentioned, we're going to go through a quick project overview with the rationale, the available knowledge that we have for this area, and a quick description of the field season 2020, the sampling campaign that we've done, and some early observations. I don't want to call that section results just yet, simply because, the field season has extended in late September. My boots are practically still wet from this one. This may have something to do with a very high water level this past summer. We'll get back to that. But yeah, just some early observations. The acknowledgements first. This was mostly funded by the Mineral Development Strategy and Polar Continental Shelf for the logistics. Thank you also for the Aurora Research Institute. Tanner Peltier, wonderful pilot from GSH that we've had this year. Dave Smith also helped us a bit in the field, and we helped him out in return. An MIP recipient, prospector from Northwest Territory. Here you can see the project area, which is roughly the NTS map sheet 85K itself. So west of Yellowknife, there's some exception to the map sheet itself. There's an area to the southwest that is part of the Horn Plateau, so we're not going there, as well as to the northeast. Part of the map sheet is in Vechico city limit, so we try to avoid that area, and also to the south, there's the Birch Lake area. It's not off limit per se, however, it's an area of cultural significance, so we just stayed out of it, out of principle. And yeah, that is the work area. The reason to go do some work in this area is, well, first of all, the accessibility. As you can see, there is highway tree that runs through a part of the map sheet, and there's also a future road that's going to go there. The Wati all-season road is being built at the moment. That goes through the area as well, so there's going to be even more accessibility in the future. And it's surprisingly a poorly understood area, given the fact that it's accessible. There's sparse data from past exploration work. None of that data is specific to drift prospecting. We don't really know very well the specific glacial history of the area, the constraint on the dispersal patterns that we may expect. We don't know the drift thickness that well, except from some areas where we have shot holes, but it's very sparse. So specifically, we're going to try and establish mineralogical and geochemical assessment of the surficial sediment, as well as still stratigraphy and transport history. That's the broader goal of the project as a whole. Some of the things we have to help us do that, we can follow up on the geophysical survey that's been done by our office a few years ago. We're going to touch on that in a little bit. And we're also putting a lot of effort into keeping our data set compatible with some data that is coming out from a actually pretty great GSC project that's being done adjacent to our work area just to the south. So we're going to talk about that as well. This project is done in synergy with an ongoing NTGS industrial material project led by my co-author, Gideon. So we're just going to touch briefly on that part of the project at the very end of the talk. If you have any questions about the bedrock investigation side of the study, please reach out to Gideon Lembiv. So the GSC study that's been done to the south of the area, it's a similar study, but with even broader goal. There's a lot of people working on it. They're doing great work. So they have a surficial geology mapping component with boots on the ground. They're combining their till survey with sediment geochemistry and heavy mineral survey, and a very thorough understanding of glacial dynamics and sediment stratigraphy in their area, as well as some radiocarbon geochronology, and actually a lot of other stuff went into their work. So we're just trying to follow up a little bit on the stuff that they've done to the south. Also, on the existing data side of things, there is a regional surficial geology map that is quite recent in the 85K map sheet in our area that's been done recently by Dan Kerr, Peter Morse, and Steve Wolf. Now, of all of the remote sensing surficial geology map that are coming out these days, I like this one, I think, the most. One of the reasons is the implication of two of the co-authors that have a lot of experience with boots on the ground in this specific area. You're quite lucky in a remote sensing project when you can have the expertise of people that have been there, and I think it makes a huge difference with this map. What they found on this map, though, is maybe a little bit different than what I would have put on the map, though, because there are people that have a long history of working in the permafrost science part of things. One of the difference, for example, you see that they are pretty heavy on the glacial lacustrine veneer. So you have large areas of this map sheet that consist of reworked till with some glacial lacustrine sediment in some areas of large reworked till, So they've been generous, I think, with the glacial lacustrine veneer. I would have probably put a little bit more till in there, but this is, we all have our own biases when it comes to making maps. So it is overall a pretty great map. The takeaway that I would say, though, is that if you're looking at that and you think, oh, it's all glacial lacustrine, there's no point doing any drift prospecting, that is not the case. There's also a huge area of till itself, till veneer, and even some till blanket in this band running from the southeast to the northwest. We're going to go back to this feature in a bit because it's actually an important feature of this area. On the bedrock geology side of things, there is not a lot of outcrop in this area. Although we do have maps that have been made, probably a lot of drill holes went into making these maps. The takeaway for our work, I would say, is if you look at this stratigraphic sequence from the east to the west, you start with the map sheet starts with mostly in the Chinchiga Formation. So right there we have very pale limestone with units of gypsum in it. And then you move to the Lonely Bay Formation, which is a much darker type of landstorm. Lots of fossils into it. Very nice pure limestone for a lot of the outcrops that we've seen. A few outcrops that are actually visible at the surface. And then we move to the Horn River Formation, which is more fissile unit, a lot of shales in there, very bituminous shales. And you can probably already guess where I'm going with this, is that you have limestone, gypsum, and shale in close proximity in an area that is accessible by road. So this is all really good stuff for the industrial mineral side of the story. But as I said, I won't touch too much on that. So there is a possibility of Proterozoic unit that are piercing through the Paleozoic cover. We see them mostly in the northeast of the map sheet, but they can have also on the east and the southeast, as well as outside of the area in the up ice direction. So one of the important things about these Proterozoic units, apart from the fact that they may point to mineral deposits of more varied type than only what you would think to expect in the sedimentary sequence, they also play a role in the dispersal and the tracing because they contain a lot of red sandstone that are popping up in the pebble that can be easily confused with rocks that comes from the east arm way further up ice. So these are easy to confuse and they may muddy the water a little bit in terms of dispersal transport history if you're not careful about their identification, if you don't know that they may occur up ice of where you're sampling. Apart from that, there's no obvious single dispersal tracer occurrence that would help deconvolute the transport history, and good luck finding striation in this area. The other piece of the puzzle that we have to help us design the sampling campaign is the Chan Lake aeromagnetic survey that's been done by Zif Mirza and also interpreted in part with Beth Fisher from our office from 2016, published in 2 different reports. So this aeromag survey identified high and low intensity domains that may be related to different geology that probably do not subcrop below the till or may subcrop below the till. We do not know that based on the absence of outcrop too. Identified a lot of dikes, faults, lineaments, and also a bunch of singular anomalies based on Keating and Euler techniques. So what these are actually identifying are pieces of the data set that may resemble the model of a kimberlite pipe. Now, we're not too sure if a kimberlite in this setting we would actually resemble that model. So these are hypotheses to be tested. So in a sense, they helped us design our till sampling campaign. Another piece of information that we have from the start are some pebble counts, a few samples, about 15 samples that were given to us by our Mineral Incentive Program prospector partner to perform some pebble counts on them. So I performed these before going into the field, and to be fair, I'm definitely not an expert into differentiating tons of Paleozoic units. So this is why a lot of the class that you can see in the picture here, you have a big clump of undifferentiated type of limestone, maybe even some sandstone in there. But the important thing is that the portion from the shield, the intrusive, and the metasets are very easy to distinguish, as well as some of the slates that points to short transport distances. We're going to know more about all the pebble transport history and all that once we do the analysis on the samples from last summer, but so far with this preliminary data set, we already have an idea that you have variety in the till sourcing right from the start. You do have a lot of them that, something that would surprise me, 65% undifferentiated Paleozoic, 20% intrusive from the slave, 5% metasediment like the Burwash Formation, etc. 5% slate and 5% redstone that may come from the east arm, may be local. I don't know yet. So that would be a till that I wouldn't raise an eyebrow about. But you can also have some of the tills that are very different, which a much greater portion of local class, a lot less intrusive, a lot less of the intrusives, much more limestone, and some which are the reverse, some that are much more skewed towards the slate. And these may be found in the same Surficial geology unit from the regional Surficial geology map, and they may sometimes be found in close proximity to one another. So again, that shows a more complex, more varied transport history there. It's something worth investigating. So with this information in hand, we've designed the 2020 till sampling campaign. We've tried to find good landing spots and relevant places to go sample that would tell us the more information for a buck based on the Arctic DEM and the S3 base map imagery to find a good landing spot, and based on the Surficial geology map and, as I've mentioned, the aeromagnetic survey. We've tried to represent the regional variability of Surficial and Bedrock geology, as well as testing the hypothesis from the Chan Lake aeromagnetic survey. We've interpreted our glacial flow on large-scale fluted landscapes, so the drumlins that are in the area, the shape of the lakes themselves are influenced by the fluted landscape because they have a control over the drainage. And we've successfully sampled 60 different sites. We've done hand-dug pits following the GEM protocol, and we've sampled for indicator minerals, till geochemistry, pebble counts, size fraction studies that will come later on. Samples for the till, geochemistry, and the indicator minerals are in the labs right now, so I don't have the results to show you so far, but there is a few interesting tidbits of information that are worth mentioning about the sampling campaign itself. I do acknowledge that there was a certain amount of bias. You can see there's more sample that are taken closer to the highway because of the work we've done from the truck. There's also a certain sampling bias linked to the geomorphology of the terrain based on the difficulty of finding good landing spot in the area, especially last year with the water level being so high. So we have some cut lines in some places that have helped us finding landing spot, but these are again closer to the highway in the big band of till that runs from the southeast to the northwest that we've already discussed briefly. So there's a little bit more sample in these units. When we go to the rest of the map sheet, even if we can find some till in the area that have been mapped as glacial lacustrine sediment, it is very, very flat and extremely swampy. It's a wet land, so with the water level being high, it was difficult to find good landing spot, and sometimes in these areas, we didn't have as much time for sampling. The machine was still running. In this picture here, you can see a heel log on the helicopter. What did help us at a few locations, as you can see here, is an interesting features of the landscape that we don't totally understand yet, but there are some areas where you find these very, very tiny dried up lake, where you have a patch of dried up getcha with those desiccation fractures. And we know that whatever happened there was pretty recent because we have these preserved, very brittle shell that are exposed at the surface. Probably related to some permafrost activity. More discussion to be had on that with different groups at our office. You see in the field that there is a small wall of hummocky features surrounding these lakes. So there's definitely some recent movements that have happened there. These hummocky features are definitely in an area where the active layer is pretty thin as opposed to the lake itself. So these consist of good landing spots actually, but this creates a sampling bias. Now I'm going to talk about a little bit about the till variability that we've observed. This is in no way a systematic description of the type of sediment we found in the area. I'm just, well, not there yet, unfortunately. But just some examples of what you may found in this picture here. As in the picture A, we have a clay-rich till that's gray. We find them in gray to light beige, usually very fresh, typically found under a very thick organic horizon. They are classed 4. This is very, very clay-rich. The clasts are highly local. In the picture next to that, we have something that almost resembled a little bit of till that you can find from the slate. Not quite though, there's still a lot more clay and silt in it. They vary in color from dark brown to light brown. Some of them can have a reddish hue when they are a little bit more reworked by Glacial Lake McConnell. There's a variety of strength of reworking in those stills. Sometimes they're more sorted than others. The sea horizon, it can vary in depth from 10 centimeter to 70 centimeters. Clast varies as well. This is where you will find up to 20-30% slave clast in them, and abundant boulders at the surface. We can also find here in the picture C what has been described before as the fine glacial lacustrine sediments veneer. This is a well-sorted sand. a few pebble in it still, and sometimes it actually overlays the thick clay of glacial McConnell per se. Very massive clays with your occasional dropstone, easy to recognize. And when you find that in the field, well, not too happy if you're looking for tails. So, but they are easy to recognize. That's the good news. Surface expression, we do have a fluted landscape in a lot of the area, although compared to what we can see in the remote sensing image, I would say is that the drumlin field per se, where you will find these huge drumlins, the 10 to 15 meter in height, is only found in the southern portion of the area. Most of the area you see the shape of the drumlin, but they've been reworked to the point that the elevation difference is maybe only plus or minus a meter. Now, did the area between the drumlin have been just so infilled that this is what is left, or is this an erosional features? I don't know yet. Stuff to be investigated, but that means the rest of the terrain is actually very flat. We also see some maybe eskers. They are rare, extremely small features. The material itself does not differ that much from the till surrounding it, just more boulders at the surface. Both of these features are distinguishable with the difference in vegetation. That's where the tree grows. Rarer, interesting expression of the surface, some outcrops that contain some oodoos, pretty rare. Here we have a cliff at the border of the Lonely Bay Formation and the Chinchiga Formation. So basically the eastern border of the Lonely Bay Formation. This is where you find a series of cliff within the limestone. This is where most of the outcrop are actually. And this corresponds mostly to the eastern edge of the big area of till within the map. So there is definitely a bedrock control on where you find the least rework amount of material and the fresh till. Now, that being said, you can still find good till outside of this area. This is where we found the outcrop, the cliff, and a portion of that is also mapped in the regional surficial geology as beach sediment in the form of a boulder lag, and this is what we've observed in the field. Now, I don't know if it's completely an erosional feature or if there just wasn't that much sediment being deposited in the first place, because when you look at these area, the picture at the bottom left of the slide, you don't see a lot of boulders that have been transported. It's mostly local rocks in these lags where you find no surficial material other than clasts and boulders. We have found a lot of karstic terrain. I don't believe these to be thermal karst. They are associated with the Chinchiga Formation, with where you find the limestone. They're pretty much everywhere you have these limestones. They're just more visible in some of the areas that are covered with well-sorted sand. This here's been taken just a little bit east of the 85K map sheet as you get closer to White Beach. You do have the same sand that are present at White Beach going really far inland, and this is where that karstic activity is very, very easy to identify. On the industrial material component, we have identified some of the elements we were looking for. Bituminous shale and gypsum. They don't outcrop per se, but you find them at the bottom of your till sediment in places where the till is extremely thin. And if it had been displaced by the glacial movement, it would be very local. None of these things would survive long transport. And as you dig, it gets more and more and more compact, almost a transition between unconsolidated and consolidated sediment. So these are good news. We've also done some investigation a little outside of the 85K on that portion of the work, following on slate studies for construction material. We haven't found a good landing spot there. That's why you have a picture from back in the day where Val went to that area that we wanted to reinvestigate. We found a really good area for granite studies for construction material, sandstone as well. So those were all successes on that part of the study. But if you want to know more about that, please reach out to Gideon. Future work, obviously the analysis of all of those samples for 2020 to add all the meat to the bones that I've just discussed. And the 2021 field campaign that we're going to do next summer, we're going to complete the regional till sampling in the areas that were not accessible this year because of the difficulty in landing locations, and as well as start a more detailed stratigraphic and transport study with Martin Ross from University of Waterloo, as well as two students, one that will start a master doing some sections within those large drumlins that we've discussed in the southern portion of the map sheet, and one student more focused on the lab work, the granulometric studies, and the pebble counts. The next summer will also include helicopter-supported work if it works out with PCSB, as well as road-supported work from a camp that I'm hoping to set in the southern portion of the map sheet. And I think that concludes this talk. Thank you very much. I hope you enjoy the rest of the symposium.